The cool, rigid outer layer of the Earth, the lithosphere, is broken into massive plates. There are about a dozen major plates and many smaller plates in continuous motion as they collide with, slide under, or move past each other in a process known as plate tectonics. A plate may be entirely oceanic lithosphere, like the Pacific Plate, or, like the North American Plate, can be part oceanic and part continental lithosphere. We will return to lithosphere types in a minute, but first, let's look inside the Earth to clarify the layers. The mantle is a 2,900 kilometer thick, high magnesium silicate rock layer located between the crust and the core. The uppermost part, the lithospheric mantle, is cooler and more rigid than the deeper mantle. It lies above a hotter and more ductile layer of similar composition called the asthenosphere. As an analogy to how rock can either be brittle or ductile, consider a taffy bar like the Big Hunk. When force is applied, they are brittle when cold and ductile when warm. Zooming in to a tectonic cross-section, we see that the lithospheric plates are composed of crust on top of the outermost rigid part of the mantle. Although the mantle has a different composition and higher density than the crust, these two layers migrate as a single mechanical layer called a lithosphere or tectonic plate. This is where earthquakes occur as the brittle rock that makes up the plates fractures and breaks. The hotter, more ductile asthenospheric rock does not fracture to produce earthquakes. Continental lithosphere, with continental crust above lithospheric mantle, typically ranges from 150 to 200 kilometers thick. Continental crust stands above sea level because it has an average thickness of 40 kilometers and is mostly made of more buoyant, silica-rich, low-density granitic, sedimentary, and metamorphic rocks, which form the continents. Oceanic lithosphere, formed at spreading ridges, is typically 50 to 140 kilometers thick. Oceanic crust is only around 8 kilometers thick and is denser than continental crust because it contains less low-density silica and more high-density iron and magnesium. Thus, it forms the ocean floor with its top surface below sea level. Relative motion between plates can be broadly grouped into three main categories: transform, divergent, and convergent. Returning to the world map view, we show transform or strike-slip boundaries are places where plates move horizontally against each other. Divergent or constructive boundaries are places where plates move apart from one another. And places where plates press into one another are called convergent or destructive boundaries. Lithosphere is neither created nor destroyed along transform boundaries, which connect segments of spreading oceanic ridges and other plate boundaries. Transform boundaries can also cut across continents, as the San Andreas Zone does in California, where it connects the East Pacific Rise to the Cascadia Subduction Zone. Shallow earthquakes on long transform boundaries that cut continental crust can approach magnitude 8, whereas those on oceanic transform boundaries tend to be much smaller. At divergent boundaries, oceanic crust forms at spreading ridges where plates pull away from each other. A small volume of the mantle melts to create the crust. The hot, buoyant, upwelling mantle supports the oceanic ridges that form the Earth's longest mountain systems. Because temperature increases rapidly with depth at divergent boundaries, there is only a thin layer of brittle rock to fracture in earthquakes. Most earthquakes occur within the upper 10 kilometers and have magnitudes that are generally less than 6. More than 75% of all earthquakes occur on or near convergent boundaries. Here, an oceanic plate is forced beneath a continental in a process called subduction. Indeed, the world's largest earthquakes occur near the shallow edge of the boundary where magnitude 9s have been recorded. At this location, stress builds up over tens to hundreds of years until it releases like a spring and can produce tsunamis. A broad zone of shallow earthquakes occurs within the overriding plate due to compressive forces near the convergent boundary. Earthquakes can reach depths of 700 kilometers within the subducting plates because the oceanic plate can remain cold and brittle as it dives into the deeper mantle. Similar processes occur when an oceanic plate subducts beneath another oceanic plate. Here, an ocean trench marks the location where the plate is pushed down into the mantle. In this case, the line of volcanoes that grows on the upper oceanic plate is an island arc. Not all convergent boundaries involve subduction. When the continental parts of converging plates come together, neither can subduct. Instead, the two continents collide, producing horizontal deformation and uplift in the continental crust to build mountains and plateaus. Frequent shallow earthquakes in the continental collision zones can exceed magnitude 8 and are generally less than 40 kilometers deep. In addition to these three boundaries, there are also diffuse boundary zones in which deformation occurs over a wide region. Although less common than earthquakes along plate boundaries, earthquakes in the interior part of plates, called intraplate earthquakes, do occur. Nevertheless, tectonic activity and earthquakes are chiefly concentrated at or near plate boundaries, where many geologic features including volcanoes, mountains, trenches, and tsunamis are in a constant state of change.